All right, welcome back to my calculus videos. This is section 7.2 in our textbook. This is called Anti-differentiation by Substitution. So, as a quick introduction, let's remind ourselves about anti-differentiation. I have the function, the integral of x squared minus sine of x dx. This is easy enough to figure out. I know that the antiderivative of x squared must be x cubed, and with a little bit of inspection, I realized that the derivative of that is going to be 3x squared, and so I put in a compensating fraction there to keep that 3 out. I also know that the derivative of cosine is sine, and so the antiderivative of sine is going to be cosine, but because there's a negative already there, I'm going to make that plus cosine, which gives me a derivative of negative sine. And then finally, I know that anytime I'm talking about an antiderivative, I need to add a constant, because when I take the derivative of that constant, I'm going to get a 0. So the derivative of this antiderivative is x squared minus sine x. Well, that's great. So why don't you go ahead and, if you're one of my students, do exercise 3 in the book, and then come on back and we'll talk about the next step. All right. So there are some properties of indefinite integrals that we have seen, we've talked about. Most of these are power formula, trig functions, that kind of thing. I'm actually going to put together a separate video where I just go through those properties. So go ahead and look for that a little bit later on in the 7.2 section. But what I want to talk about now is I want to talk about verifying formulas, and then we're going to get into, well, what if it's too complicated? What if I don't know the actual antiderivative of the function? So let's do another quick example. This was example 1. Let's do a quick example, example 2. And we're going to look at 2 quick antiderivatives. We'll start with the integral of u to the negative 1 du. We know that u to the negative 1 means 1 over u, and we know that the antiderivative of 1 over u is natural log. And make sure you put the absolute value on there. Remember, natural log, any log function, is not defined for negative numbers. So this is not true if u is negative. So it's very important that we say, well, we can find the antiderivative, but we need to turn u into a positive number first. And then again, plus a constant, always plus a constant. So how do we know if that's correct? Well, I take the derivative with respect to u of the natural log of u plus the constant. The derivative of natural log is 1 over. I don't need the absolute values anymore because 1 over is defined for positive and negative values. The derivative of the constant is 0. I've double checked. And I've recommended to my students that you just do this every time you come up with an antiderivative. So let's do one more related, the integral of natural log of u du. And notice that in this case, I don't need the absolute values because negative values of u are not in the domain of the function that I'm trying to integrate, trying to find the area under that curve. And there's nothing to integrate to the left of the axis. So I'm going to actually give you this one because we don't know the antiderivative of natural log, and I'm going to tell you that it is u times natural log of u minus u plus a constant. Now you may be thinking to yourself, well, I don't know that I believe you. What if you're wrong? Well, let's check. We'll take the derivative of u natural log of u minus u plus the constant. Let's see what it's equal to. Well, The derivative of u, natural log of u, that is a product, so it's going to be product rule, which means the derivative of u, which is 1 times natural log of u, plus u times the derivative of natural log of u, minus the derivative of u, which is 1, plus the derivative of a constant, which is 0. Doing a little simplification, we see that this is natural log of u plus 1 minus 1, which is natural log of u, which means that my antiderivative was in fact correct. All right, my students, go ahead and do exercise 11 out of the book.